Algebra 2, Lesson 11-1 Review. Write each expression in radical form. Simplify numerical expressions when possible. Okay, radical form looks something like this right here. Okay, and that one there's for square root. This one here is for cube root, and then the fourth root, and so on and so on. So we're going to take this right here, and we're going to write it in radical form. It becomes the 6th root of 64 to the 5th power. Okay. If we go and look, let's go to our calculator, and we'll write it there. Let's see here. You can write, let's see, control and then square root, and then you put 6 root of 64. And let's go over here and we'll close parentheses, and that'll put it all in. And then caret 5. And that gives you 32. So this is 32. Now, you can also just, the way it is right there, 64 caret, and then control, divide, and then 5 over 6, and that gives you 32 there. All right, not a problem. When they're numbers, it's really easy to use the calculator. But what happens when you have a variable? That's when you actually gotta go about it. All right, so 6x to the 3/2 power. So that's going to be the square root of 6x, and the cube applies to everything, so we're going to put it up there. And also make sure when you're writing these square roots that you're writing it up here in the superscript part. Okay, up here. Notice it, how that because and that's in the, because this right here, 6 square root of 64 to the 6th to the 5th power is not the same as that right there. Okay, and I've noticed a lot of you tend to do that. You don't put it in the superscript position. Let's take a look at this one here. Now we got the cube root of -8 to the 4th power. Well, what happens to the cube root of -8 is -2. So that's going to be -2 to the 4th power, which is, well, 4 times 4 times 4. That's going to be 16. Okay, and let's try that in our calculator. Let's try that in our calculator just to make sure. Open parentheses, -8, close parentheses, caret, and then we've got, what is it? 4/3. So control, divide, 4 over 3, and that gives you positive 16. And well, hold on, that radical. Remember, square roots don't have a negative, but cube roots do. Cube roots can have a negative. Okay, so let's try that. Let's try that. And the cube root of -8, and then close parentheses, caret 4. That's going to give you 16 as well. Okay. All right. What about number 4 here? Let's see. So this is going to be the 4th root of 5r cubed. Okay. And 27, that's going to be the cube root of 27, which is 3. So that's going to be 3 squared, which is 9. And 100a to the 1/2 power, that's going to be the square root of 100a. All right. Well, we know the square root of 100 is 10, so that's going to give us 10 times the square root of a. Okay. And let's see here, number 7. So we got the 5th root of 10 to the 8th power. That's about as far as we can take that. Now this in here is kind of cool. Let's see here. That's going to be x, and that's going to be 2 times 2/5, which is going to be x to the 4/5, or the 5th root of x to the 4th power. And let's try this one here. Let's see here. Now it's got a negative in it. What happens when it's a negative? You put a 1 over it, and you got the cube root of 7x. And let me show you that. Let's see here. Let's go to our calculator. We'll show it in the calculator. 2 caret negative 2. That's going to give you 1/4. Okay? And I mean, that would be the same as 1 control divide 2 squared. See what I'm talking about? All right. And let's see here. Now we're going to write each expression by using rational exponents. Okay, so now it's in radical form, and we're going to change it to rational. So 7/4. 2 to the 7/4. That's going to give you 5x, and that's going to be 3/2. Okay, I can't take that any further. This is going to be 51 to the 4/5. Oh, here one. The square root of 169 is 13, so that's going to be 13 cubed. 13 cubed, and I don't know what that is off the top of my head. 13 caret 3. I got 2197, so that's 2197. All right. This is going to be 2v to the 3/4. Notice this exponent becomes the numerator, and the radicand becomes the denominator. Aha. All right. So this is going to be n squared to the 2/5, and that's going to become n to the 4/5. All right. This is down here in the denominator. We can move it up. We can move it up. So that's going to be the square root of 3m, and we're going to put negative cubed, and then so that's going to become 3m to the negative 3/2. Negative 3/2. All right. And what about here? This becomes 36 to the 14/7. 14 divided by 7 is 2, so that's 36 squared. I don't know what that is off the top of my head, so we'll do that right there. 1296. 1296. Aha. So now we're going to have, it's going to be the 4th root of 5p, and we'll put to the negative 7. So it's going to end up being 5p to the negative 7/4. All right, not a problem. Moving right through this one here. In every atom, electrons orbit the nucleus with a certain characteristic velocity known as the Fermi-Thomas velocity. And it's equal to z to the 2/3 over 137 times c, where z is the number of protons in the nucleus and c is the speed of light. In terms of c, what is the characteristic Fermi-Thomas velocity of the electrons in uranium, for which z equals 92? So we'll just rewrite it as 92 to the 2/3 over 137 times c. All right, and then 92 caret, and that was 2/3, 2 over 3, and I got 20 point something or another. So that's going to be 20.3794 over 137 times C. And we'll go back here and we'll just divide by 30. 137. 137. And that gives us 0.1487. All right, so 0.14875 and so on. See, so that's approximately 0.15 C. All right, not a problem. Good job on lesson 1 there. Let's try lesson 2, review for lesson 2. Simplifying radical expressions. So we're going to simplify each expression. Assume all variables are positive. All right. So what do we got here? Now we get to play with these. Let's see here. Let's see, that's -3 and see 12. That's like 4 times 3 times r. And the square root of 4 is 2. 2 times -3, that would give you -6 times the square root of 3r. See what I did there? All right, let's look at here. Aha. Now what are we going to do here? Remember, if you have x squared times x squared, that is x to the 2 plus 2, which is x to the 4th. So let's add these. Let's see, what do we got? 4, and that's 3 halves plus 5 halves, and that's 4, and that's 8 halves, which is 4 to the 4th power. Okay, 4 to the 4th power. So let's try that. Let's see, what is 4 to the 4th power? 4 caret 4, I get 256. So that's 256. Let's try that. Just, let's just check it with the calculator because, sometimes I make a little mistake there. And let's see, what do we got? 3 over 2, 3 over 2. And that was times, times, and then we got 4 caret, control, divide, and then we've got 5 halves, 5 over 2, and let's press enter. We got 256. Okay, so that did work. Not too shabby. What about here? Well, we got 27, and that's going to be to the 4/3. And since this is on the bottom, that'll be -2/3. And that's going to give you 27. 4 minus 2 is 2, so that's 2/3. And let's see, the cube root of 27 squared, that's going to give you, let's see, cube root of 27 is 3. 3 squared, which is 9. So our answer is 9. Let's try that in our calculator just to be sure. Control, divide, and then we got 27 caret, and that's 4/3. And then we got 27 caret, and that's 2/3. 9. All right, so it worked out. Why do we need to know this? Well, what if you're on Barbados sitting there and you're drinking you a nice lemonade and it's hot and stuff and somebody offers you another one? There you go. All right, so we've got, well, that's going to be a to the 4th, a to the 4th, and this is 4. That would be like 8 halves. So we're going to put 8 halves minus 3 halves. Okay, minus 3 halves. And then down here on the bottom, b, that would be like 2 halves, right? So that's going to give us b to the 3 halves. Okay, and make that b a little bit bigger. So we're going to have a to the 5 halves over b to the 3 halves. Okay. Got a problem here. We're not supposed to have a fraction down there in the denominator. Okay, so we need to get rid of that. How do we get rid of that? How do we get rid of that? What if we multiply that times b to the 1/2 over b to the 1/2? Okay, so we don't actually change the equation. That's going to give us a to the 5/2 times b to the 1/2 over, and then 3/2 plus 1/2 would be 4/2. So that would give you b squared. Okay, so that's proper form right there. Okay, these both equal the same. These two both equal the same. Well, let's see that right there. Those both equal the same, but the rules say that we've got to simplify it. It said simplify. Okay, so you would see it like this on a test, not like that right there. All right. All right. 5. Let's see here. You know what's really neat about this? This right here. Watch it. The cube root of 27 times the cube root of 64 squared. All right. Because see, that's a big old number. And what that's going to give you 3 times 4. Okay, that's going to get 3 times 4. That's 12, right? So that's going to give you 12 squared, which is 144. See how you can do that in your head? Let's try that with a calculator, just make sure. So 27 times 64 caret. And then we're going to do 2 over 3. 2 over 3. 1/4. Glad that worked. All right. So what do we got here? Well, that's 243 is on the bottom. Okay. So this is going to be 1 to the 1/5 over 243 to the 1/5. Huh. All right, so that's 1 to the 1/5 is just 1, and 243, that would be the 5th root of 243. The 5th root of 243. So that's just going to give you 1/3. All right, good deal. Number 7. Okay, let's try a little treachery here. Let's see, you got 5x to the 3. Well, 25, isn't that like 5 squared? Huh. So what do we got here? Okay. Let's see, 5 squared. So we got 5 squared times 3/2. So, and that's going to be x to the 3/2. And let's see here. I'm doing too many steps at once. I'm doing too many. So we've got, yeah, let's see, 5 and 5. Let's distribute 25 to the 3/2 times x to the 3/2 over 5, and then x to the 1/2. Okay, so 25 to the 3/2 is going to be 25 to the 3/2. That's going to be, well, 5 squared times 3/2, and that's like 2 over 1, so those cancel out. That gives you 5 to the 3rd power, which is 125. So that's going to give you 125, and then x to the 3/2 minus 1/2 over 5. Okay, now 125 divided by 5 is 25. Okay, And then x, 3 halves minus 1 half is 2 halves. So that's 2 halves. And 2 divided by 2 is 1. So our final answer is 25x. All right. You got 4x to the negative 1 half times 9x to the 1 half. This is going to be, that's got a negative, so we're going to have 9x to the 1 half over 4x to the 1 half. Okay. So 9 to the 1 half times x to the 1 half over 4 to the 1 half times x to the 1 half. 9 to the 1 half is 3. 4 to the 1 half is 2. The square root of 4 is 2. The square root of 9 is 3. And then you have x, and that's going to be 1 half minus 1 half, which is just going to give you 3 over 2. All right. What about here? How do we do this? Well, what's the cube root of 81? Let's see here. So we got 3. And let's see here. The cube root of, and I think 81 is 27 times 3 times x cubed times x times y squared. All right, so the cube root of 27 is 3. 3 times 3 is 9. All right, so that takes care of that and that. And then x cubed, that's going to take an x out. All right. And this, the rest of this has to stay inside because there's not enough. So we have 3xy squared. Not too shabby. Okay. Let's try this one here. We've got, that's going to be negative 5 and the square root of, now we have negative 500. Okay. So I'm thinking that's going to be negative 125 times 4. Let's try that. Negative 125 times 4. That gives you negative 500. So there we go. That covers the negative 500. And this is the cube root, right? So let's put that. I'm kind of blocking that up. Let me fix that. So that's a cube right there, and this is negative 5 here. All right, and then we've got x cubed times x squared, and then we have y cubed. All right, so negative 125, the cube of negative 125 is negative 5. Negative 5 times negative 5, so we got negative 5 times negative 5. I took that out. All right, the 4 has to stay in. I can take an x out times x, and that, oh, and I can take a y out times y, and then that's going to give you the cube root. That's going to, what's left in there? 4x squared. So negative 25 times negative 25 is 25xy times the cube root of 4x squared. And there's your final answer. All right, we can kind of work with those. Number 11, the frequency f in hertz at which a simple pendulum rocks back and forth is given by f equals 1 over 2 pi times the square root of g over I, where g is the strength of the gravitational field at the location of the pendulum, and I is the length of the pendulum. All right. Cool. Rewrite the formula so that it gives the length L of the pendulum in terms of G and F. Oh, I thought that was an I, that's an L. All right, so we're going to rewrite it as L equals. So we have F equals 1 over 2 pi times the square root of G over, and I'm going to make an L like that. So I'm going to multiply both sides. So I got 2 pi times f equals the square root of g over L. I'm going to square both sides. So I got 2 pi f squared equals, and that's going to give me g over L. Multiply both sides by L. So I got L times 2 pi f squared equals g. Then divide both sides by 2 pi f squared. So L equals g over 2 pi f squared. Okay, and that's squared. Make it where that's a bit more legible. All right, now we did that. Then simplify the formula using the fact that the gravitational field is approximately 32 feet second squared. So we're going to put a 32 in here. So we've got L equals 32 over 2 pi f squared. Well, I can do some simplifying here. So I got 32 over, and then 2 squared is 4 times pi f squared. So 2 squared was 4. That's what I did there. And then those cancel out, and I get 8 over pi f squared. So there's our formula. Let me write that. Let's see. 8 over pi f squared. Now, use the equation found in part A to find the length of the pendulum to the nearest foot that has a frequency of 0.52 hertz. So I'm going to put 0.52 in for f. So L equals, and that's going to be 8 over pi times 0.52 and squared. And let me rewrite that. 8 over 0.52 pi squared. And let's see here. Let's go to our calculator. Control divide 8 over, and open parentheses, 0.52, and then pi, close parentheses, squared, enter. And I get 2.997, which is approximately 3 feet. All right, good deal. Now it's on to number 3, solving radical equations. Practice and problem solving. So what do we got here? Solve each equation. How do I get rid of the radical? How do I get rid of the radical? Does anybody remember? Let's try squaring both sides. All right, if we square both sides, that gets rid of the radical, and we can solve for x, what I was trying to say. So let's square both sides. Squared and squared. And that's going to give me x plus 6 equals 49. Then I'm going to subtract 6 from both sides, and I get x equals 43. Okay. Here, square both sides. And I get 5x equals 100. Divide both sides by 5. And I get x equals 20. Not a problem. Listen here. Square both sides. And I get 2x plus 5 equals 3x minus 1. Subtract 2x from both sides. I get 5 equals x minus 1. Add 1 to both sides. I get x equals 6. Here. This is going to be a little tricky. All right. So I get x plus 4, and then 3 squared is 9, and 9x. All right. So subtract x from both sides. I get 4 equals 8x. Divide both sides by 8, and I get 1/2 equals x. Uh-oh. Now we're going to cube both sides here. Cube. And I get x minus 6 equals 3x plus 24. Subtract x from both sides. I got negative 6 equals 2x plus 24. Subtract 24 from both sides. I got negative 30 equals 2x. Divide both sides by 2, and I get negative 15 equals x. We're going to cube both sides here. And that, well, what is 3 cubed? That gives you 27x equals, and that's going to be 7x plus 5. Subtract 7x from both sides. I get 20x equals 5. Divide both sides by 20, and I get x equals 1/4. All right. Now, all of these you can do in your calculator. It's real easy, and I'm going to show you. Let's see here. Number 5. Let's go to our calculator. And we're going to do menu 3, 1. That's in solve. And we'll put in the cube root of x minus 6. X minus 6 equals, and then we got to put in the cube root of 3x plus 24. 3x plus 24, and then get outside. And then comma, we are looking for the x, so comma x, press enter, and it gives us negative 15. Okay. Now, these right here, you can do in solve, but the problem with that is sometimes you get, well, you have an extraneous value, okay? And in solve will only give you 1, where you might actually have 2, okay? So let's try this. Let's square that, and let's square that. All right, and what do we get? We get negative, and I'm probably going to need some real estate here. I'm going to need some real estate here. All right. So you got x minus 3. So that's going to give you negative 14x plus 2 equals x minus 3 squared. Now you got to multiply that. So that means x minus 3 times x minus 3. So you got negative 14x plus 2 equals x times, that's going to be x squared minus 6x plus 9. Okay. Now let's add 14x to both sides, and you got x squared plus 8x plus 9. And then we're going to subtract 2 from both sides, and you got x squared plus 8x plus 7. Okay. You factor that gives you x minus 7, x minus 7 times x minus 1. And what do we have here? So x minus 7 equals 0, x minus 1 equals 0. And let's see, add 7 to both sides. So you got x equals 7, add 1 to both sides, x equals 1. Okay, it looks like we have a solution, doesn't it? What's the problem with that? What's the problem with that? What is the problem? The square root of, you've put 1 in there, that's negative 14 plus, all right, let's just do it here. Negative 14 times 7 plus 2, all right, and let's see, negative 14 times 7. Negative 14 times 7 equals negative 98. Equals the square root of negative 98 plus 2, which is going to be the square root of negative 96. No solution. All right, does not work. Let's try the other one. Negative 14 times 1 plus 2, that's going to give you the square root of negative 14 plus 2, which is the square root of negative 12. No solution. So this one here is no solution. Okay, no solution. So let's go to our calculator. Let's see here and let's try graphing. Let's graph it. Okay, so tab, and we got the square root of negative 14x plus 2. Enter, and it looks like that. And then press tab, and you got x minus 3. X minus 3. They don't cross, do they? They don't cross at all. That's why there's no solution. All right. And let's see here. On new document. No. Let's go back to number 5. Let's go back to number 5, and we'll try that. And you got the cube root of x minus 6. Enter. And then tab, control, and you got the cube root of, and that's 3x plus 24. 3x plus 24. Where do they cross at? Let's see. Right here. That's where they cross at. Menu 6, 4, and negative 15. Is that not what our solution was earlier? Negative 15 it was. We go back here, and it was negative 15 right here. See what I'm saying? Okay. So let's try number 8. Number 8. I need some real estate here. Number 8. Give me some fresh real estate. What do we got here? I'm going to square both sides, and I get x plus 4 equals 36. I'm going to subtract 4 from both sides, and I get x equals 32. So x equals 32. And you can graph those in your calculator, and you'll see what they work. Let's try number 9. And number 9. Okay. First, we're going to square both sides. Okay, so we can get rid of that 1/2 right there. 4 squared, that's going to give you 16, and then that's going to be x minus 3 equals, and then 8 squared is 64. Okay. Divide both sides by 16, so you got 64 divided by 16. That's not what I wanted. 64 divided by 16, and that gives me 4. So I've got x minus 3 equals 4. That's x minus 3 equals 4. And add 3 to both sides, I get x equals 7. Okay. Again, you can graph these, and they will give you the solution. Okay. So we got 4 open parentheses, x minus 3, x minus 3, close parentheses, caret 1, control, divide 2. Graph that. And then graph 8. Tab 8. I don't see it. Oh, there it is. And then let's find this point. Menu 6, 4, and look at there, 7. Is that not our answer? It is. Okay. Let's see. What do we do here? I'm gonna, let's see, number 10. We're gonna divide both sides by 4. And that's gonna give us x minus 12 to the 1/3 equals -4. All right. Now, let's cube both sides. So we can get rid of that 1/3. And that's going to give us x minus 12 equals, and then -4 cubed. -4 caret 3, 64, -64 equals -64. We're going to add 12 to both sides, and we get x equals, and that would be -52. Okay, so there we go. Not too bad. Number 11. Let's see here. Pretty easy. Let's just square both sides. And we got 3x plus 6 equals 9. Subtract 6 from both sides. We got 3x equals 3. So x equals 1. Over here, you can, but it's easier to go ahead and subtract 3 from both sides. So you got the square root of x minus 4 equals 6. Square both sides, and you got x minus 4 equals 36. Let me show what I did here. All right. And then add 4 to both sides, and you got x equals 40. And, you can do that in a calculator, too. Let's see. Let's try number 12. Menu 3, 1, and what do we got here? We got the square root of x minus 4, x minus 4. Go outside of the radical and put plus 3, and that equals 9. And don't forget to tell it what to look for. We're looking for the x, and 40, same thing that we got before. What about here? Square both sides. And you got x plus 7 equals 2x minus 1. Subtract x from both sides, and you get 7. 7 equals x minus 1. Add 1 to both sides, and you got x equals 8. Over here, we're going to square both sides. And that gives us 2x minus 7. Equals 4x squared. And then, so I'm going to move everything. So I got 0 equals 4x squared minus 2x minus 7. Okay, we got to factor that. That's pretty hard to factor. Let's go in here and graph it. So let's see, on new document, no, graph. We got, what was it, 4x. Oh, man, I hate when I do that. 4x squared. And then we got minus 2x, minus 2x, minus 7. Graph. Aha, look at there. Crosses right here. And right, where are those spots? Menu 6, 1, and that's 1.6. Menu 6, 1, and that's negative 1.1. Okay, well, what's the problem with that? What is the problem with that? Negative, so it gave me x equals negative 1.1, and x equals, what was the other one? 1.6. 1.6. If you put that in the if you put that in here, let's see, you got the square root of 2 times negative 1.1 minus 7. That's going to give you, well, that equals, that's the square root of negative 2.2 minus 7, which is the square root of negative 9.2. Can't do that. And let's try the square root of 2 times 1.6 minus 7. And then what do we got here? That's the square root of 3.2 minus 7. And that's the square root of negative 3.8. Can't do that either. So this one here is no solution. Okay, no solution. You have to check your answers and make sure they work. All right. Number 15. A biologist is studying two species of animals in a habitat. The population P sub 1 of one of the species is growing according to P sub 1 equals 500 T to the 3 power, and the population P sub 2 of the other species is growing according to P sub 2 equals 100 T squared, where time T is measured in years. After how many years will the two populations of the two species be equal? So it's asking, when is P sub 1 going to equal P sub 2? Well, we can figure that out. We got 500 T 3/2 equals 100 T squared. All right. So what do we do here? Well, let's divide both sides by 100. And that gives us 5T to the 3/2 equals T squared. All right. Divide both sides by T to the 3/2, so that gives you 5 equals T squared over T 3/2. And T squared equals T to the 4/2, right? We can agree on that. So if you have, so 5 equals T to the 4/2 minus 3/2. So that gives you 5 equals T to the 1/2. Well, if you square both sides, you get 25 equals T. You know, what if, Mr. Carpenter, what if I had a hard time solving all that? What would be another way I could do it? Good question. I'm glad you asked. Let's graph both of them. But you got to graph them on separate lines. Okay, so you got 500 x caret 3 control divide 2. 500 x 3/2. All right. And then, and then tab, let's graph the other one. 100 x squared. Well, gee whiz, that is going to be hard to find. Scrolling. Yeah, it's getting large fast. Okay, it's getting large fast. What if I menu, zoom, and zoom out? 4, and zoom out. Well, now it looks like a straight line almost. Okay. Escape. How can I find menu, 4, and zoom back in. Let's zoom back in. Okay. Here we are. Okay. Now, where do they cross at? Where do they cross at? How about menu 6, 4, and then we'll here, and then we'll hit it over here somewhere. No intersection found in the specified bounds. Let's see here. Menu 6, 4. No menu 6, 4, and let's hit it here. And we know somewhere over here, somewhere it's got to. There it is, 25. Okay, there it is, 25. But so it can be hard to find it that way. So there you go. All right, folks, good job. Good luck on the test tomorrow. Have a nice evening and see you tomorrow.